So in this case, the graphs of f of x equals negative x squared minus 4x plus 5 and g of x equals x plus q are sketched below and display the following essential properties. Points E and P are the x-intercepts of f. Point M is the y-intercept, and point N is the turning point of f. The dotted line ND is the axis of symmetry of f. The graphs of f and g intersect at points E and M respectively. And the word respectively doesn't mean you have to respect point E and M. It actually means in that order. Point T is the point of intersection of G, which is the straight line, with the axis of symmetry of F. Points S and M are symmetrical with respect to the axis of symmetry of F. So each and every point they gave you here, a bullet, it's what I'm referring to. It's essential for your success in answering each and every question here. Right. Now let's look at the first question. This is our nice graph we can see. It's very nice. The first question says, write down the value of Q. So if we look at Q, we understand it's the y-intercept of the straight line, g of x, right? But this is what they told us. They said the point M is the point of intersection of both f and g. And one thing we know is that the y-intercept of f is 5. So this means the y-intercept of g is bound to be 5 as well, because that's where they intersect. So we say the value of q is positive 5. Then the next question says, calculate the length of line segment EP. So if you give EP a good look, you understand it's a horizontal length. And every time you must calculate the horizontal distance, you have to consider the x values only. So you say the bigger x value, which is at P, minus the smaller x value, which is at E. But if you understand the situation, you know that we don't know the coordinates of E as well as P. So we need to start by finding them. But it's easy to do so because we already know the equation of f of x. And we understand these are the x-intercepts of the parabolic function. So let's go to the whiteboard and easily calculate the x-intercepts. So they said to us, the equation of f of x is negative x squared minus 4x, and then we say plus 5. For x-intercept, we have to let y to be 0. So this is what we have. But because the coefficient of x squared is negative, we need to divide throughout by -1. So this is what we get after doing so. Now we factorize this quadratic equation by opening two brackets. Then we say factors of x squared, it's x and x. And factors of 5, such that if we add or subtract, we have to get 4. It can only be 5 and 1. The bigger number takes the sign of the middle term, non-negotiable, and this one has to be negative. We apply our zero factor law. So this means the value of x will simply be -5, or it's just going to be +1. So these are the two x-intercept. But now one thing we know is that the point E is on the negative x-axis. So it means the coordinates of point E will simply be -5 and 0. Then the coordinates of point P will simply be 1 and 0. So when finding the length of EP, we say the x value at P minus the x value at E. Just like when you find displacement, final minus initial. Do you see that? So you say it's 1 minus -5. So negative times negative is a positive. And 1 plus 5 will give you 6 units. And then your happiness is complete. So let's look at the next question. It says, determine the coordinates of point N. Remember, in one of the bullets, they said to you, point N is the turning point of F. So remember, in order for us to find the coordinates of the turning point, we can use one of two ways. And when you get to grade 12, you learn there's another way, the third way, which is differentiating the function. Oh, sorry about that. I forgot you are still young. So yeah, this is the formula we use. So we say the value of B in the original equation is -4. And then we say the value of A is -1. So +4 divided by -2 will simply give us -2. So now that we know the x coordinate of the turning point, then we simply substitute this into the original equation in order to find the corresponding y value. So this is what we get. And when we substitute this into our calculator, we find that the value of the y coordinate of the turning point is 9. So this therefore means the coordinates of the point N will be -2 and 9. Over and out. Now, what does the next question say? It says, determine the equation of a straight line, H, which is perpendicular to G, passing through the point N. So here we need to remember what we learned in analytical geometry regarding perpendicular lines. We know that if two lines are perpendicular, the product of their gradients will give us -1. So that's the concept we use. We say the gradient of H multiplied by the gradient of G must give us -1. But when we remember the equation of G, we said it's x plus q. The q which we said is 5. So the value of the gradient is +1. So we say the gradient of H times +1 equals -1. So this means the gradient of H will just be -1. So now that we know the gradient of H, we can either use y equals mx plus c, or we can use y minus y1 equals m into x minus x1 in order to find the equation of H. But let's just use the first one. So we say the gradient is -1. The x value of the point through which h passes, it's -2. Because they said it passes through the turning point of the parabolic function. -1 by -2, it's +2. Taking the +2 to the left, it becomes negative. 9 minus 2 will give you +7. So this therefore means the equation of h of x will be -x plus 7. And once again, your happiness is complete. What does the next one say? Let's see. Well, the next question says, calculate the average gradient between the points M and N. So the average gradient is just a normal gradient. There is no difference. And fortunately enough, we know the coordinates of point N. We also know the coordinates of point M. So it's literally a walk in a park. Imagine. Imagine seated in the exam and yet walking in the park. Yeah, it's nice. Guys, it's a joke. You should be laughing now. Right. So let's find this average gradient. We said it's the normal gradient, so you shouldn't stress that much. So you say the average gradient, of course, you can write it in full if you like. In fact, it's preferable that you write it in full, or you can still use M. It's acceptable as well. So we say it's the y value at M minus the y value at N divided by the x value at M minus x value at N. Of course, you could have said y value at N minus at M, and then x value at N minus at M. It's up to you. The order is not so important. Now, the y value at M is 5. The y value at N is 9. X value at M is 0. X value at N is -2. So 5 minus 9 is -4. 0 plus 2, it's 2. And then -4 divided by 2 will just give you a nice -2. So that's just your average gradient. There was nothing special about it. Now the next question, 7.6, it says, calculate the length of line NT. So if you look at line NT, you can see that it's a vertical length. So always when calculating a vertical distance, you only consider the y values. So you say the bigger y value, which is at N, minus the smaller y value, which is at T. But now one thing you know is that the y value at N is known, but at T, it's unknown. That's when you go to one of the bullets, the one that says the point T is the point of intersection of the straight line with the axis of symmetry of F. So by that, they were telling you that the x coordinate of T is -2. That's what they were telling you. So you now know the x coordinate. Yours is to find the y coordinate at t. Of course, you substitute -2 into the equation of g. So let's go and do that. So we can easily find our vertical length. So we say g of -2 will just be -2 plus 5, which will give us +3. Then we say, in order for us to find the vertical length and t, we take the bigger y value, then we subtract the smaller y value. So we say 9 minus 3 will simply give us 6 units as well. So that's your vertical length and t. Right. So let's see what does the next question say. So we can kill it. Well, the next question says, determine the coordinates of point S for 3 marks. So in order for you to find the coordinates of point S, you need to go to the last bullet. They said to you point S and M are symmetrical with respect to the axis of symmetry of F. So by this, they are saying to you, the distance from the point M to the axis of symmetry will be equal to the distance from the axis of symmetry to the point S. So what we know is that the distance from the point M to the axis of symmetry is 2 units, because the x coordinate of the axis of symmetry is -2. So this means from the axis of symmetry to point S will be 2 units as well, meaning the x coordinate of point S will be -4. That's how we determined it. So now that we know the x coordinate of point S, then we can substitute this -4 into the original equation in order to find the y coordinate of this point. So we'll say, we can simply go to our function and say, this is the equation of f of x. And then we say, what is f of -4? It's just negative into -4 squared. And then we say that. Then we say +5. And if we substitute this into our original equation, we are simply going to get +5. Oh, there was no need for us to determine this because it's just a horizontal line. Oh, sorry about that, guys. There was no need for us to determine it. So the most important thing was finding the x coordinate of point S. That was the most important thing. But what I did was to find this x coordinate by using inspection, by applying the concept of symmetry and by using inspection. You could have also said, well, if I look at the line SM, it's just a horizontal line. So if it's a horizontal line, it means the y value at S will be 5. Do you see that? So in order to find the x value by calculations, you could have said, what is the x value for which the y value will be 5? So meaning you equate this function to 5 and then you want to solve for x. So when you do, let's take everything to the left so that it becomes positive. So you have x squared plus 4x, but 5 minus 5 will just give you 0. Then you say x is the highest common factor. If I take it out, I'm left with x plus 4. Then I apply my zero factor law, and then I find that x is negative 4. Do you see that? Yes. And then you can safely say the coordinates of the point S are negative 4 and 5. So whether you did it by inspection as I did before, or by calculation, it's perfectly fine. Horizontal line SM, meaning the y values are the same. That's the most important thing. Right. But even if you just wrote point S and its coordinates without any calculations, you would have still got your full marks, because the examiner understands that you understand the concept of symmetrical. Yo, sorry about that. I've done a lot of talking, I know. I apologize. Now it's time to look at the last two questions, which are the most interesting in this paper. The first one says, for which values of x will f of x minus g of x equal to 0? In other words, find the values of x such that if we say the y value on f minus the y value on g, the answer is 0. Well, there's only one way for you to get an answer of 0, is if the two y values are equal. And where the two y values are equal, it's where the two functions intersect. Do you see that? So yeah, that's all we have to do. We just have to go to the points of intersection. Then we can see at point E, both of these y values are 0. Yes, both of these y values are 0. Sorry about that, guys. There's someone calling. Yeah, I think we are fine now. We can proceed. Is it still recording? Of course it is. So yeah. Right. So yes, we said if we look at point E, the y value on f is 0. The y value on g is also 0. So 0 minus 0, it's 0. If we look at point M, the y value on f is 0. Y value on g is 0. Sorry. Oh, I'm distracted by the call now. The y values are each 5 at point M. Oh, sorry, guys. So 5 minus 5 will just be 0. So those are your two values of x. You'll just say x equals -5 or x equals 0. These are the x coordinates of the points of intersection. It's where the two y values are equal, and therefore this value minus this will give us 0. Then the last question says, for which values of x will f of x times g of x be less than 0? In other words, where is the y value on the function of f multiplied by the y value on the function of g will result in a negative answer. So what is the key to this? You need to look for where one function is above the x-axis and the other is below the x-axis. They must be opposite in sign. One must be positive, the other must be negative. So here let's look at 3 intervals. From negative infinity to point E, which is -5. And then we look at -5 to 0. Then we look at 0 to 1. And then from 1 to infinity. It's actually 4 intervals. So if we look at negative infinity to point E, both of these graphs are negative. So negative times negative is a positive. It's not our solution. If we look at -5 to 0, well, both of these graphs are positive. So if we multiply positive values, we get a positive value. It's not a solution as well. If we look at 0 to 1, both of them are positive. But if we look at 1, which is point P, all the way to infinity, the function of f is negative, but the function of g is positive. So negative times a positive will give us a negative. So here you'll say it's any value of x that is greater than 1. Or you can say any value from 1 all the way to infinity. Yes, and then your happiness will be complete. I'm really sorry about the call, guys. Please forgive me. Yes, but thank you so much for watching. I really hope this helps a lot.